Okay, we're going to do a factorial ANOVA by hand. This is going to be a new type of video. We're going to try to teach you the critical vocabulary words and the statistical concepts that are connected to them. So let's get going here. So this is part one. There's, I believe, 13 parts to this. I'm going to try to make them all about 5 minutes apiece so I don't bore you to death. But this is what we call the Super Rats Smoothies research study. Okay, it's a factorial ANOVA. And here's the study. Can we increase the number of rat push-ups with either drugs and or smoothies? Okay. So we take 36 rats, filthy stinking rats, and we're gonna give them either a serum in one of 3 doses or a smoothie, either a large or a small, and a combination of the serum and the smoothies, and we're going to make them do push-ups. So we're going to see if there's going to be a difference between the number of rat push-ups due to the different levels of rat serum and or the different sizes of the health smoothie that the rats are going to drink. This is what we call a two-way ANOVA. It's also called a factorial ANOVA. In this nomenclature, the factor simply means IV, independent variable. And our IVs in this are going to be the serum, the amount of serum, and the size of the smoothie. So this is how we write up a factorial ANOVA. Our study is called a 3x2 ANOVA because the first IV is the serum levels. And we're going to have a control group with 0, and one group's going to get 10 milligrams, and the last group's going to get 20 milligrams. Those are called levels of the IV, also called subgroups of the one IV. Our other IV is going to be the size of the smoothie. It's either large or small. Okay, so it's 2 levels. So that's how you write up our ANOVA. Just tells you each individual number represents an IV, and the number tells you how many levels in that IV. Okay, so let's continue. With a factorial ANOVA, you have to look for what we call interaction. That's when something is going on between the IVs, that they're working together, they're interacting with each other in such a way that they affect the DV like a totally different IV. They're acting like a new IV, but only when they're working together, and that's called interaction, and that's something we have to check for in a factorial ANOVA. Different than a one-way ANOVA, right? One way, just one IV. So with our study, factor A, it's going to be the first IV1. It's the rat serum, and there's 3 different levels, or 3 different subgroups, okay? The IV is rat serum, and the differentiating factor is going to be how much they get. So the first group gets none. They're the control group. Second gets a low dose, 10 milligrams, and the third group gets the high dose, 20 milligrams. And hopefully, they're claiming that the more serum these guys do, the more push-ups they're going to do. So that's what we're going to test. Factor B is the IV2, the rat smoothies, yum yum. And there's 2 levels or 2 subgroups, right? It's just going to be a small and a large. It's probably sponsored by Jamba Juice. But now we've identified our IVs, and our DV is the number of rat push-ups, right? How many push-ups can these guys do? After the drug and after the smoothie. So that's what the nature of this research is all about. All right, so we know factor A is the serum, factor B is the size of the smoothie, and the DV is the number of rat push-ups. So the new thing that we have to check, the new variance, right? That's what ANOVAs do. It analyzes the variance, is what we call AB. Okay, that is the interaction variance. So we got to see if that is happening with our study. Interaction. That's the difference between a one-way ANOVA and a factorial ANOVA, right? You got to see if they're working together somehow. And here's the raw data. We're going to go ahead and make a table for it. So the top row going across is factor A at the 3 different levels, right? A1 is 0, A2 is 10, A3 is 20. And the the y-axis up here is going to be our factor B, and that's the smoothie size. And B1 is small, B2 is large. So now we go ahead and make this into a table. And then we're going to fill in the scores from each 6 of the rats. So there's going to be 6 rats at A1B1, which translates into they had no serum and a small smoothie. And that's how you read these across. We could have put these in different order. It doesn't matter, right? We could have put the B's on top and the A's on the side. It doesn't matter. But these cells represents each treatment the rats get in that cell, right? So 10 milligrams small smoothies, 20 milligrams small smoothies. In the bottom row is the same drug amount, but they're all in the large smoothies. So they all got treated, and they were all given a push-up test, right? They counted how many push-ups they did. So, but we're going to switch to a different table. So A1B1 is control group with the small smoothie, right? It looks just like this. It would be this one, A1B1. A1B2 would be the control group, no serum at the large smoothie. And that's the way it's usually written in most of the books, okay? So, but that's what these mean, right? And here are the actual DVs. So this is everybody in the control group, right, for small smoothies and for large smoothies. And here's the second group. That is, what is that? That is 10 milligrams small, 10 milligrams large. And this last one is 20 milligrams small, 20 milligrams large. And that tells us that we're going to run an ANOVA here. Okay. I think we're just going to wrap this up as the end of part 1. Thank you. Please watch the other videos. MGZ out.